Question says the diagram shows a ring of mass 2 kgs. If it is 2 kgs, it is 20 newtons downwards. Threaded on a fixed rough vertical rod. So we are going to deal with friction. A light string is attached to the ring and is pulled upwards at an angle of 30 degrees to the horizontal. The tension in this string is T newtons. The coefficient of friction between the ring and the rod is 0.24. Find the two values of T for which the ring is in limiting equilibrium. Now it is in limiting equilibrium, that means it is about to move either up or down. So these two conditions will give us two values of T. So let's consider for the first case upwards. Let's consider it is about to move up. Before doing that, I'm splitting up. This is T cos of 30. This is T sine of 30. Weight is drawn. This is rough. So when we are considering that it is about to move up, friction is acting downwards and normal contact force is towards left hand side. Now luckily left hand side and right hand side there is only one force each. Upwards and downwards there are three forces. So I can say R is equals to T cos of 30, and when we write down the vertical forces, I can say upward force is T sine 30 is equal to the two downward forces, that is friction plus 20. So T sine 30, we know that friction is mu R plus 20. R is already written. T sine 30 is equals to mu is 0.24. R is T cos of 30 plus 20. Now it is just algebra. We make T the subject of the formula, T sine 30 minus T 0.24 cos of 30 is equals to 20. Taking out T common, sine 30 minus 0.24 cos of 30. You can use calculator at any stage. I'm just dragging it down to keep it as exact as I can. 30 minus 0.24 cos of 30, and the tension is 20 over sine 30 minus 0.24 cos of 30, and I'm getting 68.457, which is approximately equal to 68.5 newtons. Now the second case, in which we consider that the ring is about to move down. So when the ring is about to move down, only change is the direction of friction. Friction is now acting upwards. If the ring is moving downwards, friction is opposite to the motion. R still stays same. R equals T cos 30. R equals T cos 30. Left equals right. And about the vertical forces, friction and T sine 30 is upwards. So friction plus T sine 30 is upwards, equal to the weight, which was 20. So friction is mu R. T sine 30 is equals to 20. Mu is 0.24. R is T cos of 30 plus T sine of 30 is equals to 20. I'm taking out this T common and dividing everything else on the other side. So T is equals to 20 over 0.24 cos of 30 plus sine of 30. And we get 28.2547, which is approximately equal to 28.3 newtons. Clear?